When we look at a massive new stadium, a gleaming suspension bridge, or even a state-of-the-art wind farm, it is so easy to be completely awestruck by the final product. And usually we credit the giant corporate entities that funded or branded them. But welcome to today's Explainer, because today we are going to look at the hidden framework behind these megaprojects. We're diving into the incredibly vital yet constantly overlooked world of the specialized engineers and building subcontractors who are quite literally building our sustainable future. These are the real unsung heroes of infrastructure, and we're going to understand their massive impact through the lens of global sustainability accounting standards. Because as it turns out, the folks actually pouring the concrete and wiring the grids, they hold the keys to our green future. Okay, let's take a quick look at our roadmap for today. We're going to cover the unsung infrastructure heroes: design, feasibility, and the environment, integrity and workforce safety, life cycle impacts and subcontractors, climate impacts and renewables, and we'll wrap it all up with ethics in complex projects. All right, let's jump right into Section 1, the unsung infrastructure heroes. So, massive infrastructure isn't just about those giant corporate entities. It's really about the highly specialized people on the ground. Generally, the industry is broken down into four major segments. You got your infrastructure construction, think dams and pipelines, and non-residential building construction, which covers stuff like factories and hospitals. Now, those two, they usually get all the glory. But for this explainer, we're focusing intensely on the other two: engineering services and building subcontractors. Engineering services include the specialized architects and feasibility consultants who draw the very first lines on a blueprint. And the building subcontractors, well, those are your plumbers, your electricians, carpenters, landscapers. They are the essential professionals who take those blueprints and turn them into a functioning, breathing reality. Now, you might be wondering, how do we actually measure the financial heartbeat of these unsung heroes? Well, we look at three standardized baseline activity metrics. First, active projects. Those are the ones currently under development. Then commissioned projects, the ones that were just completed and deemed ready for service. And finally, the big one, the total backlog. This is the massive pool of contractually expected revenue for projects that just aren't completed yet. This backlog is literally the lifeblood for engineering services and subcontractors. It represents their entire future survival and growth. Moving right along to Section 2, design, feasibility, and environment. Think about this for a second. The very first pencil sketch by an architect or an engineer can completely determine the environmental fate of a project. Engineering services actually act as the very first line of defense for our environment. Way before a single shovel hits the dirt, these experts are out there conducting feasibility studies. They're assessing the baseline ecological impacts of a site. They have to figure out how to navigate really complex local legal requirements, protect local biodiversity, and map out crucial things like stormwater management. Because honestly, if an engineering service fails to properly assess a slope or soil disturbance early on, that can lead to massive delays, intense community pushback, and absolutely crushing regulatory fines down the road. It's really helpful to think of sustainability as a relay race. On one hand, you have the pre-construction design, which is led by engineering services. They handle all the high-level planning, finding environmentally preferable alternatives, assessing those ecological impacts. And then, they pass the baton to the operational phase during construction, which is heavily reliant on the building subcontractors. These are the folks physically on site who have to actively implement waste management, control hazardous chemicals, and limit water discharges. So the engineers draw the map, but the subcontractors have to navigate the actual physical terrain, often mitigating totally unforeseen environmental issues in real time. And that brings us to Section 3, integrity and workforce safety. We are now entering a seriously high-stakes world where mistakes are incredibly expensive. An architect's miscalculation can literally cost lives, not to mention millions of dollars. In the construction industry, this is known as defect and safety-related rework. And to be clear, this isn't just when a client changes their mind about a paint color. Rework is when field activities actually have to be done over again because of a fundamental error or a safety issue. It represents severe financial losses, totally wasted materials, and massive potential legal liabilities stemming from failures in architectural design or flawed subcontractor execution. It is a complete drain on a project's profitability. Check out this number, 200,000. When we talk about safety, this is the baseline used to calculate the total recordable incident rate, or TIR. Why 200,000? Well, it represents the total hours that 100 full-time workers spend on site in a given year, assuming 40 hours a week for 50 weeks. It sounds like just a mathematical constant, sure, but it really humanizes the massive scale of workforce safety. It reminds us that we are tracking the actual lives and the well-being of hundreds of individuals working around heavy machinery, precarious heights, and hazardous materials every single day. And what's absolutely vital to understand here is that massive infrastructure entities are held accountable for everyone on their site. They have to report safety statistics not just for their direct employees, the folks on their actual payroll, but also for contract employees. This includes the independent subcontractors, the electricians hired through a temp agency, the independent carpenters. Basically, a single subcontracted plumber's safety directly impacts the massive corporate bottom line and their ability to win future bids. All right, moving into Section 4, Life Cycle Impacts and Subcontractors. A building's environmental impact absolutely does not end when construction is finished. Actually, its energy and water consumption over the next few decades is its biggest footprint by far. Clients are increasingly demanding third-party sustainability certifications, like BREEAM or LEED. But here's the thing. While the giant corporate building entity gets to hang that shiny plaque on the wall, it is the granular, precise work of the subcontractors that actually earned it. Plumbers are the ones installing the complex water collection and reuse designs. Electricians are out there wiring the energy-efficient lighting and smart grid connectivity. Landscapers are strategically placing shading devices to naturally cool the building. So why does this matter so much? Because global investors demand standardized sustainability metrics for all of this. They want to know exactly how many active and commissioned projects are actively seeking these multi-attribute sustainability certifications. Those incredibly specific trade-specific efficiency efforts by the plumbers and electricians, they directly roll up into these high-level financial disclosures. Without the subcontractors executing flawlessly on the ground, the macro-level sustainability goals of the entire project just completely fall apart. Let's zoom out a bit for Section 5, Climate Impacts and Renewables. When we step back from the individual buildings, we find massive climate impacts hidden right inside a company's future business mix. And this creates a really fascinating tension within an infrastructure company's backlog. Investors nowadays want to see a very clear breakdown of future projects. They're comparing the amount of money tied up in carbon-intensive, hydrocarbon-related projects, like coal plants and oil pipelines, against the rapidly growing market for renewable energy projects like wind and solar, and non-energy climate mitigation projects like mass transit systems or carbon capture facilities. Just to be perfectly clear, hydrocarbon-related projects mean anything directly associated with the hydrocarbon value chain, from exploration and extraction all the way to fossil fuel-based electricity generation. And engineering services, they are the true pivot point here. An engineering firm's ability to shift their architectural and design expertise away from these high-risk hydrocarbon projects and pivot toward renewables and climate mitigation is what will largely define their future survival. If they can't adapt those feasibility studies and designs for the green economy, their future backlog isn't just at risk, it's going to be obsolete. Finally, we hit Section 6, Ethics in Complex Projects. Now we have to talk about the dark side of global infrastructure. The gravity of this situation really cannot be overstated. When corporate entities operate on a massive global scale, they are managing thousands of local subcontractors, labor brokers, and material suppliers. And this creates a huge, opaque web where bribery and corruption can incredibly easily take root. Paying off a local official just to secure a permit or bypassing a safety inspection to speed up an electrician's work, that can result in devastating fines and completely shattered corporate reputations. To combat this, sustainability standards literally force entities to transparently report their financial exposure in high-risk areas. Specifically, they have to disclose their active projects and their backlog value in the 20 countries with the lowest scores on Transparency International's Corruption Perception Index, or CPI. Investors absolutely need to know exactly how much of a company's future revenue is reliant on regions where the risk of having to pay bribes, where corruption is just seen as the cost of doing business, is exceptionally high, along with the risk of subsequent monetary losses from legal proceedings. But ethical risks aren't just international bribes happening overseas. They happen right at home during the bidding process. We see these fascinating yet completely illegal anti-competitive practices. For instance, complementary bidding, also known as cover bidding. Basically, this is when an entity purposely submits an artificially high or unacceptable bid just to give the illusion of competition with zero intention of actually winning. Crazy, right? Then there's bid pooling, where competitors illegally coordinate behind closed doors to carve up massive contracts like a pie. These practices directly undermine the entire competitive process of securing vital public infrastructure funds. So I'll leave you with this thought. We've seen how engineering services design the crucial environmental safeguards and how building subcontractors actually build the energy efficiencies we so desperately need. They truly are the hidden framework. But if these architects, plumbers, and electricians hold the keys to our sustainable future on the ground, how are we holding the massive global entities that employ them financially and ethically accountable? Well, by tracking these precise metrics, from safety to backlog to ethics, we can ensure that the unsung heroes of infrastructure are building a world that is not only structurally sound, but fundamentally sustainable. Thanks so much for joining me on this explainer, and keep learning.